Good morning, Manula Prasanth here. So today's topic is a method of heat transfer. Um, we have five models totally. That means conduction, convection, heat transfer, and heat transfer equipments and evaporator. So based on these five topics, we come to this heat transfer model, that is PC 6501. The first unit goes to that conduction. Before we go to this topic, this heat transfer is the main part of all the petrochemical industries and the refineries. Then even small scale industries itself, it is very, very important. Then chemical industries also, the sugar industry, cement industries, mostly all the industries that heat transfer is very must, and all the industries that heat transfer equipment such as that heat exchangers like 1,2 shell and tube heat exchanger and 2,2 shell and tube heat exchanger, double pipe heat exchangers, then condenser, evaporators, is all heat transfer equipments. So very, very important topic itself. So basically, very fundamentally, the heat transfer, that method of heat transfer, there are three main methods, that is conduction, convection and radiation. This conduction heat transfers through something, it needs something through solid material. This, if you give heat to some solid material, this solid material heat transfer to the liquid. So here I have some media that is called as a solid media. The solid moves to the liquid. So it's basically it's a conduction. Then second one is convection. This convection is transfer with air or liquid that is moving actually. Basically the whole area of convection is heated. The third one is radiation. This radiation does not need any media. It's just for radiation through sunlight. For example, if you wear some black shirts, when you go to the outside of the sunlight absorbs radiation, absorbs sunlight and it radiates. So basically the conduction, convection, radiations is the mode of heat transfer basically. Then further, there are mainly three laws based on this heat transfer. Mainly three laws. The first law is actually Fourier's law of heat conduction. This law explains how much heat temperature is transferred to some particular area. That means Q is equal to the directly proportional to that temperature as well as area. Followed by that convection have some laws, that is Newton's law of cooling. Then third one is Stefan-Boltzmann constant. So based on these three laws, this mode of heat transfer is explained. Furthermore, some basic concepts we need to know, that is heat flux, what is meant by heat flux, and what is meant by thermal conductivity, and what is meant by a lattice, what is meant by moving of free electrons, what is meant by that equilibrium, state of equilibrium. These are all the basic things we need to know. So what is meant by thermal conductivity? So thermal conductivity, the material, then how much of amount that is capable to store, At the same time, heat flux is how much of heat spreaded over to that particular area. So these small things we need to know to calculate that Q value. That means Q is directly proportional to that A into, that means area into temperature gradient or temperature difference. Furthermore, where K is thermal conductivity, we need to calculate everything so that the particular area, how much of heat is transferred. Similarly, that Newton's law of cooling also we have some based on some formula, we need to explain how it transfers. Similarly, Stephen's Boltzmann law also implies that how much of radiation is transferred to that means E is directly proportional to T power 4. So this is very basics. Then followed that this topic will cover that three important part. That means how much transfer. For example, how much heat transferred through some flat surfaces or cylindrical surfaces, then square surfaces or sphere surfaces, something like how much it transfers. Some slab surfaces it have multiple type of slabs, not only single slab. It's a multiple type of slab, and each and every part how it transfers. So this difference from T to some T outlet, T inlet to T outlet, total surface, how much temperature is absorbed and it released. So this is quite interesting to calculate how much of amount it transfer. So this is the main part actually, how much of heat transfer to the steady state or unsteady state through this through slab surfaces or cylindrical surfaces and radial surfaces. So next model we detail about that steady state transfer through then single dimension slab or multiple slab surfaces. Then next we go for the sphere and the radial sphere and the circle, how your heat is transferred through.